Valerio, welcome to the Democratizing SEO podcast. How are you doing today?
Thanks. Thanks for having me. I'm doing great. How are you doing?
Yes, very well, thank you. Very, very well. Today we're going to talk about entity learning, information delivery systems. And you have a very interesting profile. You're an knowledge engineer and you work for an AI and knowledge graph tech startup. What is your current role at the company?
My role is my title is senior knowledge engineer, but really my role is a sort of a hybrid, I would say, of knowledge engineer. So understanding how to make knowledge graphs for our existing clients, but at the same time is almost sort of an evangelist. So explaining to prospective clients or partners or anybody who's interested why should they even bother with knowledge graphs, right? So often we see that some new technology comes along and everybody's excited for it, but it's really a pointless exercise, I think, when you sort of try to adopt some new technology without understanding it, without understanding what it does, and if you don't understand what it does and why it's useful, then all you're going to end up doing is you can end up replacing a solution that works perfectly fine, let's say in SQL, with something that you didn't need to replace it with. Instead, I think what we ought to focus on is doing the things that we can't currently do or can't currently do well by using knowledge graphs. So my job is really to sort of understand and articulate this for our clients, for our partners, and so on.
How long have you been a knowledge engineer?
So I joined about 6 years ago, but it wasn't until a year or two into the job that I was given the title of knowledge engineer.
I came across the phrase on you guys' website, KRR, knowledge representation and reasoning. And the reasoning part struck a chord with me. I found it very fascinating. How is the reasoning factored into a knowledge graph engineering?
Okay, that's a good question. So when we talk about knowledge representation, if I can just take a step back, that means what do you think it means, right? There is knowledge, and you're trying to represent it in a way that is machine readable. And of course, that is you want to be able to have flexibility and to link it and so on, because that's the nature of the knowledge. So what the graph does is it enables you to more seamlessly map the knowledge that's in your head or in a book or in a manual into the computer. That's the first thing. But then once you've mapped that knowledge, regardless of how well you map it, there are some concepts that as a human you'd be able to infer, but as a machine you're not able to infer. For instance, my son, I am his father, right? If I represent the information in the computer as saying, Valerio has son X, and then I ask you who is X's father, you would know that it's Valerio. But a computer is stupid, so they don't know. So what you need to add on top of the knowledge representation is the reasoning part. So the ability to infer extra knowledge from the knowledge that is represented. And so you can think of it as a sort of one more discipline within AI, or you can think it as a sort of a tool in the day-to-day management of the database, right? So you want to be able to maybe speed up some queries or make some queries easier to read and write, or maybe you want to harmonize data. Maybe you have some data that's in one way and on the left, on the right, and some other data that's in a different way on the left, but conceptually it's the same. And with reasoning, you can make it you can make it such that that is harmonized, and you can query it in either one way or the other at the same time.
Doesn't this open up the scope for inaccuracies?
With reasoning?
Yeah.
Well, so, okay, maybe I should have said the way that reasoning works is in a completely deterministic way, right? So you will specify a logic, and this logic will be applied to the data, and regardless of the order of the logic or the order of updates to the data or the logic, the reasoner should come to the same set of results, and it's mathematically guaranteed to be correct according to the logic and the data. So it's not really a type of machine learning inferencing that I'm talking about, where you sort of try to predict links in the graph by embedding it as a vector or anything like that. You specify a logic. You specify wherever you see that A has child B, you need to add that B has parent A, and it will do that all the time. And if it doesn't, it's a bug.
The whole entity learning aspect of knowledge graphs and semantic search is fascinating to me. One, because I'm an SEO, and two, because I see where things are headed from a worldwide web point of view. And my interest is in speaking with knowledge engineers to sort of like gauge, because you guys know, you see the end goal, right? You know exactly how things work, and I can infer. I think SEOs can infer the way things are headed by listening to folks like you who are knowledge specialists. And when it comes to entity learning, Google's objective is to organize the world's information, right? And in the early years, they acquired data in an, I would say, indirect way that wasn't necessarily knowledge based. Social media looked into entities first, right? And I think that had a heavy influence on search, Google, and the way things are shaping up these days. Is it better to learn about an entity and then the context associated with the entity? Or is it better to grab any and all data and then figure out the best entities associated with the data?
Yeah. I mean, I'm not sure I really understand the question, actually. But I guess what I would say is there's always a big difference between having a small and concise data set and keeping and managing that, and managing a data set the size of Google's knowledge graph, or even the whole web that they index, right? So when you do things at scale, you have to make all sort of trade-offs and make engineering decisions that enable you to achieve some sort of goal that wouldn't necessarily make sense otherwise. But maybe I misunderstand your question slightly.
So let me backtrack and talk about entities. So my understanding of entities is they're essentially a name, place, or thing, right? So from an SEO point of view, I'm looking at it as brands. Any and everything that's a brand is an entity. And knowledge graphs helps with the entities. Am I correct with that so far?
Well, yeah, knowledge graph helps you store the entity and anything related to it. But whatever it is that you're storing is really up to you to decide and to find it and to sort of put it into the graph. What the graph does is it helps you store it easily and represent the knowledge as easily as possible. hence knowledge representation. And, you can also look in the graph for things that might be related to the brand as you are constructing the graph, right?
So once you have all of this information, how is it then updated?
How do you update information in the graph?
Yeah. Let's say, so you initially, let's stick with an entity. And then, in fact, let's zero in and talk about people. So a personal knowledge graph, right, of people, individuals.
Yeah.
If we're trying to find out information about individuals, people, and we're using knowledge graphs for this, there is almost, I see it almost as a two-step process. So the first step is to acquire the information in the first place, i.e. know about the entities. And the second step is to keep the entities information updated on an ongoing basis. How is this second step carried out or handled?
Okay, I see. That's a good question. How do you do that? Well, I mean, from a sort of a mechanical point of view, it's really simple. You get the new data and you add it into the knowledge graph. You can do it with the Sparkle query language. You can do it with the native way that most graphs offer to add data and or remove data. So yeah, that's how it works mechanically. In terms of from a process point of view, well, again, yeah, I think that really depends a lot on what it is that you're trying to, what the specific use case is, right? So in the case of personal knowledge graphs, what do we have? We've got information about people, and some of that might change. So the name and date of birth will probably not change very often, although sometimes they do if somebody gets married or whatever. Some other information like employment will work more often, right? It will change more often, or whether they have children and such. So yeah, there it becomes a case of understanding how can we. You decide before, basically, what sort of knowledge will I want to keep updated and how, and you represent the knowledge from the beginning in such a way that that it's possible to make changes in the future, and then when you do have new data, you update the graph with the new data according to the workflow that you'd envisaged. Now, the really important part here is, if you later on have to change your mind because there was something that you hadn't thought about, then you can sort of, with a graph, it's much, much simpler to do that than, let's say, with the SQL or with MongoDB and so on, while still retaining really consistent data. And reasoning also is a key part of that, because with reasoning, you can remodel the data in a declarative way, which means that it's just much more simple to add new to remodel the data according to a different structure.
Does the reasoning take into account the person or use case of the searcher? And to give you some background to this question, with search when someone searches on Google, there is, how can I explain this? You have the point of view of the searcher, the point of view of Google itself, the provider, and the point of view of websites, right? Publishers. And it's down to each person to define precisely Oh, there's an echo. Can you still hear me?
Yeah, I can hear.
Oh, I was hearing an echo there.
Oh, sorry about
Okay.
that.
Okay. We'll keep going. Hopefully I can edit it out. So the point of view of a searcher, it's the onus is on them to use the appropriate terms to find what they are seeking, right? So use the appropriate language to search for something. It's the onus on Google or the search engine is to be able to gauge what the searcher is seeking as well as finds the information. And the onus on the publisher is to be found by search engines and users, right? So when you're factoring reasoning into a knowledge engineering, are you considering what the searcher will potentially be seeking as well?
I mean, yeah, I think that's one of the applications of graphs is for SEO. Obviously, there are others. I personally don't have that much experience with SEO. But I would say reasoning is really good at creating new links between existing entities. It's not necessarily great at actually, let me take that back. So because reasoning is good at creating new links between existing entities, and these different entities might have different labels, then when you search for any of those labels, you will be fewer links away from what you need, what you're really searching for, if that makes sense.
Mm-hmm.
Having said that, often the problem of understanding what a user means is not really something that's deterministic as much as probabilistic, right? So you try to understand patterns in the queries that users have and understand what they really mean, and that's a statistics / machine learning problem. And then once you're there, it sort of helps you understand what the user's intent is. But then, there's still 50% of the problem, if not more, which is, okay, well, now I know what they want, but how do I find it? And how do I find all the relevant information in the best possible way? And how do I maintain that information for in a sort of enterprise level application that I have, right? So I think reasoning is really good at that, more than necessarily the search part.
Right.
If you think about it, we can. I've just done some work with full text indices like Solr and Elasticsearch and so on, and they're really good at indexing text, right? So you have a nice bit of text, and then you do your search, your string query. You type a string, and it finds the text where it is, where it occurs, I would say. But then once you've done that, that's the range of questions you can ask is where is it, or how many times does it occur, et cetera, et cetera. Now there's a place for that, but also there's a place for being able to ask more complex questions. So, and even engines like Google and sort of struggling in edge cases that are on that edge. So if I say what language, I did this search a couple of weeks back. If I ask what language do they speak in Moscow, well, I say, oh, Russian, because Moscow is in Russia, etc., etc. But if I ask Google, what language do they speak in a minor town in Russia, like Omsk, then it says, oh, I don't know. Well, here's a link to a page that that tells you, and it says, well, they speak Russian, but they also speak, some Central Asian language and so on. With reasoning, you're able to say, look, if the city is in Russia or in a Russian-speaking region, I should say, then they speak Russian. And again, there's a lot of complexity because sometimes only 50% of the people speak Russian and so on. But the key point is that reasoning lets you say that from the point of view of what language they speak, Moscow is the same as as Omsk, which is the same as, some other town in the middle of nowhere, which is something that you as a human know. But when you take but you need to sort of really have a notion of entities and a notion of how they relate to each other, and yeah, so a graph with reasoning, I would say, is the best way to do that.
Do you think graphs will get to a point where they can reason the way a human can?
Yeah, that's a good question. Not
Or better, or better than
well,
a
then I
human can?
better. I think, yeah, most machines are really good at doing very simple things very fast, right? So I'll never be able to remember, 2 billion entities and all the stuff about them like a graph does. Having said that, you're able to recognize patterns, and you're able to perform very complicated reasoning and so on as a human on a smaller scale. I think a graph, maybe in the future. I mean, who knows? I'm no Steve Jobs. I think it will. I think the type of, yeah, what type of, can we reason as, yeah, okay. I think perhaps what's going to happen is there's going to be a good integration of the reasoning as is now, which I don't think can get that much better, with probabilistic type reasoning, right? Recognizing patterns and so on. So that's one of the things that I think would be quite useful. So you have a data set that may or may not be complete, and you might have some reasoning that you add to it to help enrich it a little bit. But then what you would have is some sort of module that does machine learning on it, or that learns things about it, and gives the user either suggestions or it enables it, or it enables the user to query the graph more more from a probabilistic point of view. So from, as you were saying, right, it will bring the part of finding what somebody means and getting what somebody means. It will sort of bring them closer, and then that's just going to make things easier for everybody. And now, currently, the two are, some people are trying to integrate them, but I've not really seen somewhere where it's completely done.
With businesses who seek a knowledge graph technology, what are the common issues that you find that they are trying to solve with a knowledge graph?
Very good question. Well, I think there's a range, really, but typically it's storing information that doesn't really fit in it doesn't really fit comfortably in a SQL schema. And at the same time, that needs to be normalized from the point of view of data governance, right? So if you create a JSON document, for instance, you can just put whatever you want in it, but then without a schema, but then it's not really normalized, and then finding it later on, if you don't really know what you're doing, becomes really tricky. So I think Graph is really good at doing both tasks. You can represent information and change your mind later in terms of the schema. At the same time, it's normalized, and when you look at one entity, you can be pretty sure that all the information about that entity is next to that entity, from the point of view of query language. So yeah, that's what they look for mostly, whether it's organizing very complex, company information and, subsidiaries and company directors and supply chain deals and so on, to parts in an industrial setting where maybe, you have 10 different ways of creating a motor, which might be compatible with an axle in 100 different ways. And when you look at the overall combinations, there are, hundreds of millions. Then using a graph, again, with reasoning is really a game changer.
When data is stored, do you factor in the way it will be accessed or searched for? What I mean by this is, if someone is searching for something via text, is it different to the way they would search via voice search, for example?
Well, no, because with voice search, you still have speech to text component, which is not in the graph, or at least not in our graph. That turns it into text, right? So, you will say, I'm looking for the iPhone 13, and then a component will understand that the waves that are in the air should be translated to the letters iPhone 13, and then you search that in the graph.
Sure. The way people search for with voice search has, I would say, more information within the search itself. So does that help with accessing information? The reason I ask this is because if someone is typing, they tend to use less words, and it tends to be more keyword based. So iPhone 13, I don't know, features. Whereas voice search tends to be more granular and or specific. So iPhone 13 features that are new compared to iPhone 12, as an example.
Oh, I see. Yeah.
So there's more details in the search with a voice search than someone who's typing. So does that change the delivery of the output?
Yeah, I don't really see that as necessarily a graph problem, right? The graph is all about retrieving information, especially information that's linked. Then, what information you retrieve and how you present the information that you've retrieved, it's really up to you. What the graph does is it makes it as easy as possible for you to do that. So you don't have to worry about retrieving the information and making sure that it's correct, and navigating through various links that might be in that information. But then once you've got that, it's really up to you what to do with it. Yeah.
With
I mean,
business,
from a conceptual point. Sorry, go on.
Yeah, sorry, go ahead.
So now I was just going to say, from a conceptual point of view, right? If I do a voice search, I mean, you say that the voice search is more detailed, which is fair enough, but there will be overlap, right? There will be somebody who searches with voice in a very concise way, and somebody who searches in text, like me, in a very wordy way. So when I search, I always write the same things that I would say. So I guess if you build any system, you ought to accommodate for both. But that's just my naive view.
I'm curious with the way you search. Do you tend to use Google search or voice search, like chatbots, AI chatbots, rather, or are you more
Ah.
old school and type on a search engine?
So, well, I've changed the way I do things sometimes. So, I mean, I'm still sort of used to Google, and I'll search for stuff on Google. Sometimes I'll do keywords. Sometimes I'll do a full, translate what I would ask to a person into text. So I would say, what is a good restaurant near such and such? But more and more, I'm also starting to use AI powered search as well. So there's this one called Perplexity it's got issues, but it's okay. I use Chat GPT as well, but even then, it's not super accurate. So recently I had a very unusual wine, and the guy told me what it was called, but I forgot. And I searched on Chat GPT, and I said, I want this wine from the south of France, and it's aged in a field, and then it's aged with this special method, and blah, blah, blah. And ChatGPT kept giving me the wrong answer every time. And I'd give it more context, and it says, oh, yes, sure, I hadn't thought about that. Here's your answer. And I was wrong. And I did that 3 or 4 times. And then eventually a friend of mine knew the one I was talking about, and he told me, and I asked ChatGPT, and ChatGPT said, oh, no, this one doesn't really match the characteristics that you had in mind. So, there are still limitations with search, whether it's on Google or AI and so on.
When you search, are you seeking the precise answer or a list of suggestions or recommendations that could be the answer, which you then have to follow up on or further research?
Well, it depends, right? So sometimes you just want to know, who is the president of Germany? A simple answer. You don't want a whole link to follow that you can then spend 2 hours searching through. Sometimes you want to sort of get resources that teach you something, right? They say, I don't know anything about Java, so what should I know about Java? And a good summary there would be good, or a link to some summaries will also be good. So it really depends. I guess from a more SEO point of view, especially when I'm buying something, I think very rarely do I just want one given product, right? Usually, and you do find these. There are comparison websites where they say, if you want to spend a lot of money, you should take this. If you want the best quality price, you should spend that. If you want something for this type of use case, you should buy this other product. So, a short list that doesn't take 3 hours to read through, with some context, for me, that's typically the best thing.
I've come across the terminology hallucinations, and I'm seeing it's a big problem within the knowledge graph machine learning world. How big of How big of an issue is this problem?
Yeah, I mean, I think hallucinations lives more in the realm of large language models.
Right. Okay.
What people know as LLMs slash, ChatGPT, Claude, and so on. And there, I think it's because I think that happens because, again, these models are statistical, and sometimes you will, and they're designed to generate text in a way that is statistical. So, they will say things that are likely to be true, but sometimes they're not, right? And sometimes they are also. So if you say, who's the president of the United States? It would say Joe Biden, and that's true. But if you ask, how tall is Valerio? I mean, how is it supposed to know? And sometimes it will know that it doesn't, and it will say, sorry, I don't know. But sometimes it will miss that, and it will say, oh, well, he's, 7'2". Why not? Or actually, no, it would say something like, it's 5'11", which is the average height or whatever, because it's likely that, that I'd be average, right? But it's wrong.
Mm.
So yeah, I mean, so it's a limitation, I think, in terms of fundamentally what an LLM can do. It can't know everything. And even if it does, it can't really it can't really reason about what it's doing. So it might give you two answers that don't make sense with each other. It might, it might say things that could be true, but aren't. And that's really why things like knowledge graphs can really help, because all of that information that's in the LLM, all of that knowledge, you'd like to represent it or some of it, in a way that is machine readable, so that the LLM can always refer back to it. So you might have heard of the term RAG, retrieval augmented generation, which means basically that the LLM will generate an answer, but it's augmented by retrieving actual factual knowledge, right? So if you ask a factual question, it will understand what bits it doesn't know, and what bits it needs to retrieve from where, and it will go and retrieve them, and then it will embed them within its answer. Now, why do you need a knowledge graph to do that? Well, you don't necessarily need a knowledge graph. Any database will do. But I think a knowledge graph is really useful because it gives you more tools to represent more varied knowledge. And also it gives you reasoning, so that it maximizes the likelihood that the LLM will hit the knowledge that it's looking for. Very simply, I could say, who is Valerio's son, but maybe the information is represented as the son has father Valerio, right?
Mm-hmm.
And we don't want the LLM to keep that in mind on top of everything else. So we can have a shorter context. We can have, we can make it more likely that either way to query the graph is acceptable, either has son or has parent. And then the LLM will give us an answer 100 twice as often.
What would you say is the biggest, or some of the biggest, challenges that knowledge graph engineers are currently facing?
A good question. I think there aren't that many tools out there to, I guess the tool ecosystem isn't necessarily as mature for graphs as for other products like, MongoDB or SQL and so on. But that's just really a virtue of having been around for a much shorter period of time. And I think the landscape is evolving really, really quickly, which is promising. But it's just a matter of learning the tools and finding the tools and believing in the people who develop the tools, and then they will come. Another challenge, not necessarily for engineers, but for, I guess, companies is, there aren't, I think a lot more companies want to do knowledge graph things than there are engineers for them. uh, but again, hopefully that's going to change soon.
Where would you say the landscape is headed if you were to project? And I'll let you decide on the time frame or how far you look ahead. But where would you say knowledge graph is headed?
Yeah. I'm not really sure, to be honest. Yeah, I mean, you can have all sort of predictions, and they will make sense based on some facts, and they will not make sense based on some other facts, and then one of them will become true in some way, shape, or form. I don't know. I think what my optimistic view is that a lot of people are going to embrace AI. A lot of companies are going to embrace AI, but they're going to understand pretty quickly that AI is going to be rubbish without any good data. And the best way to ensure that you have good data that's linked and is findable and it's sort of in a good position to power your AI is to have a knowledge graph, and then they'll start building knowledge graphs. And in fact, I think we're already seeing this a lot. But it's just going to explode. Just like before, you had, I think if you take a look from a more sort of historical point of view, from my limited knowledge, I think in the past you used to have sort of, and when I say the past, I mean 50 years ago, you used to have your nice big mainframe with some sort of computer program running on it, and it would store all the data within it. All right. And then people said, actually, why are we bothering? Why don't we just store the data within a database, and then we create an application to run in another logical component of the computer, and then when it needs some data, we can sort of get it from there. And doing that really enables you to build much more interesting and exciting applications. So it's not just that you have more RAM or more such and such. It's that you've decoupled the two components from a logical point of view. And I think as we get more and more AI, now the knowledge that the AI uses is stored within the AI. But my hope, my prediction is that we're going to have an AI that stores some knowledge sometimes in memory, but most of the knowledge that it needs is actually, of the factual knowledge that it needs is actually stored in a database. And I think the best way for that database to be is a knowledge graph, right? So you decouple from the AI, you decouple the sort of the machine learning part and you decouple the AI part that understands what the user, that understands the user's question with the graph from a logical point of view. Now, this totally contradicts what I just said earlier, but I think, but yeah, I mean, the two are going to be brought. I think we're going to use AI and graphs together. But at the same time, I think the graphs will come closer to AI, maybe. That's what I'm trying to say. And the AI will leverage graphs, partly because it's easier once the graph is closer to it, if that makes sense.
Mm-hmm. Mm-hmm. Lastly, Valerio, every business should know this about semantic search. What would this be?
Good question. Well, I don't know. I'll just say it's very nice and awesome. That's what you should know. It's yeah. I mean, it's not necessarily. It takes a little bit more effort than normal search, right? To implement, but it just saves so much time. When I look for stuff on SharePoint or whatever, I spend so much time, waste so much time, frankly, looking for whatever it is that I'm looking for, because there isn't really a concept of entity, and so does everybody else in the world, right? When they're at work and they work with computers instead of on a building site, they spend a ton of time, they waste a ton of time looking for stuff, and sometimes recreating stuff, like a presentation that somebody's already given, but you can't find it, so you just make your own again, or instead of adapting it, and so on. And yeah, and if we can stop doing that, we're gonna save so much time and money. Yeah, as everybody's trying to solve the productivity crisis, at least in England, and I think that's going to be a really big factor. Can you find stuff on computers easily? Right?
Yeah, totally.
And semantic search is going to do that. I mean, in terms of getting there, I don't think it's realistic to think that every company is going to have their own semantic search expert who's a proficient in RDF and Sparkle and reasoning and so on. So what we need is some people to make some really great tools that make it foolproof to implement semantic search, right? You install it you click a link and it brings an executable on your on your computer or whatever it is, and it indexes all your data and it understands all the entities. And it doesn't have to be perfect, but you always start with something that's really useful, and then when lots of people buy into it, you can sort of invest that money that they give you to improve the product.
Valerio, thank you so much for your time today. Where's the best place for people to find you online?
Yeah, great question. So, well, I'm on LinkedIn at Valerio Cocchi. And also you can check out our website, which is rdfox.com. So that's rdfox.com.
Awesome. I'll have those two links in the description so people can get in touch with you. Valerio, thank you so much for your time. Have a brilliant day. Thanks for being on.
Thanks, Austine. Have a great one.